Hey guys, it's Dr. Jansen. Today we're going to solve a problem by substitution when one variable is already isolated. So let's get started. So in this equation, we see that y is by itself, all the way to the left, isolated all alone. That's what isolated means in the first equation, right here. And then in the lower equation, we see y show up again, right here. And so the way we're going to solve this is we're actually going to substitute y into the second equation. Well, the way we do that, you're like, well, y in the top equation is equal to all of this. Yeah, we're actually going to substitute all of that into the second equation. We can still swap y and y just as if the same as if y was equal to just 3 or something like that, and we were substituting just 3. We can still substitute y even though it's equal to this whole big thing of 2x plus 1. So that's what we're going to do. So I'm going to rewrite this second equation and then because anytime we substitute something in for a variable, so even as we substitute 2x plus 1 in for y right here, anytime we substitute something in for a variable, it always has to go in parentheses to keep it safe. And then I'm going to copy down the rest of the equation. And now we're going to solve using our order of operations, which I know you guys are all familiar with. So moving left to right, we are going to distribute, which means just to give out to everything inside of those parentheses. And we know that means to multiply. So 4 times 2x is going to give us 8x. 4 times positive 1, we always have to check that sign over here to the left of our number, means positive is going to give us positive 4 right there. And then we're going to copy down the rest of our equation. And now we're going to continue to solve using the order of operations moving left to right. So the next thing we're going to do is combine like terms. First, we're going to combine these like terms of our variable terms right here. Again, we have to check our sign. So here to the left, we see we have a negative 3. 8x minus 3x gives us 5x. Copy down the rest of our problem. Continuing to combine those like terms. Well, we can't. We don't have any more like terms on the same side. So now we're solving our equation, and we're going to move all of those number terms over to one side. So I'm going to subtract 4 to get all my number terms on one side. And we're going to be left with 5x equals 15. Continuing to solve. Using the order of operations, the only thing left to do is to divide to get x alone. And I'm left with 15 divided by 5, which is 3. Now here's the thing though. Every single answer to a system of equation is not just one number. Every single answer to a system of equations is an ordered pair, x comma y. So right now we have half of our answer. We have 3, which is our x value, but we still need to find our y value. I shouldn't write that. That looks like a 0. But we still need to find our y value, okay? But the good news is over here, back at the very beginning of our equation, we had this equation that was already set to y. It said y is equal to 2x plus 1. So let's rewrite that. Y equals 2x plus 1. And we now have an x value. We know that x and 3 are the same thing. So just like we substituted in the first step, we can swap 3 in for x right here. So we're going to do that. So we're going to substitute 3 in for x in the same way we did in the first step. Anytime we substitute a number in for a variable, we have to put in parentheses to keep it safe. So substitute 3 in for 2. Which tells us that we are going to multiply. So y equals 6. So we'll have to add that 1. And we get y equals 7. So again, y equals 7 is not my answer. X equals 3 is not my answer. The answer is my ordered pair, 3, 7. And that is the answer to this entire system of equations right here that we just solved using substitution. Great job.